In the digital age, social media serves as a primary platform for sharing information, but it also enables the rapid spread of misinformation. This issue is addressed in a research paper titled, Bridging Cognition and Emotion: Empathy-Driven Multimodal Misinformation Detection, by Zihan Wang and colleagues from the Communication University of China. The paper begins by highlighting how misinformation acts like a digital plague, spreading quickly and disrupting public perception, social consensus, and even policy decisions. Traditional methods for detecting misinformation often focus on surface-level features, such as analyzing text, user behavior, or images. While some studies have incorporated emotional signals to improve accuracy, they tend to overlook deeper psychological factors, like how creators intentionally manipulate emotions and how readers' cognitive biases influence their interpretation. To tackle this gap, the researchers propose the dual-aspect empathy framework, or DAE. This framework draws from psychology's concept of empathy, which has two main dimensions: cognitive empathy and emotional empathy. Cognitive empathy involves understanding someone else's thoughts, beliefs, and intentions, while emotional empathy focuses on feeling and sharing in their emotions. By integrating these, DAE analyzes misinformation from both the creator's and the reader's perspectives, making the detection process more human-centric and comprehensive. Let's break this down. From the creator's side, the framework examines their cognitive strategies and emotional appeals. For instance, creators might use tactics to evoke strong feelings like fear or anger to make their content more shareable. The paper points out that misinformation often relies on these emotional hooks to bypass rational thinking. By applying cognitive empathy, DAE helps uncover the underlying motives, such as what the creator is trying to achieve by presenting information in a certain way. On the reader's side, DAE simulates how people might cognitively judge and emotionally respond to the content. This is achieved using large language models, or LLMs, which are advanced AI systems capable of generating human-like text and reasoning. The framework uses these models to mimic readers' perspectives, predicting things like emotional reactions or doubts that might arise. For example, if a piece of misinformation claims something shocking, the simulation could reveal whether a reader might initially feel alarmed but then question it based on their own experiences. The paper includes an example to illustrate this. Imagine a social media post saying, "Breaking news. Over 60% of vaccinated women experience fertility issues, yet the government dares not reveal the truth." From an emotional standpoint, this could stir up fear and distrust, prompting people to share it widely. But through cognitive empathy, we might analyze the creator's intent. They're using exaggerated claims to exploit health concerns. Then, simulating the reader's response, DAE might consider factors like personal knowledge of vaccine safety, leading to thoughts like, "This seems off because I don't know anyone affected." By combining these views, it's easier to identify the content as misinformation rather than falling for the emotional trap. Building on this, the researchers introduce an empathy-aware filtering mechanism. This tool enhances the authenticity and diversity of responses generated by the AI. It ensures that the simulations aren't just generic but account for variations in how different people might react, based on their backgrounds or biases. This makes the framework more robust for real-world applications, where misinformation can affect diverse audiences. In terms of methodology, DAE is designed for multimodal misinformation, meaning it handles not just text but also images, videos, and other media types. The paper explains that by processing these elements through the lens of empathy, the system can detect subtle cues that traditional methods miss. For instance, an image paired with inflammatory text might be flagged because the emotional appeal doesn't align with cognitive scrutiny. The researchers conducted experiments on benchmark datasets to test DAE's effectiveness. Their results show that it outperforms existing methods in accuracy and reliability. This is likely because DAE's human-centric approach captures the nuanced interplay between cognition and emotion, which is central to how misinformation spreads and is perceived. Throughout the paper, the authors emphasize that empathy isn't just a theoretical concept. It's a practical tool for rebuilding trust in information ecosystems. By understanding both the what, the cognitive strategies, and the how, the emotional impacts, DAE provides a novel paradigm for detection. This integration of psychology and AI represents a significant advancement, potentially helping to curb the spread of false information on social media. In the introduction, the paper references various studies to support its claims, such as how misinformation disrupts public policies and how emotional signals have been used in prior detection efforts. It cites sources like those exploring text analysis, user behavior, and image recognition, underscoring that while these are valuable, they're incomplete without empathy. Moving deeper into the framework, DAY operates by first processing the content to extract key features. Then, it applies cognitive empathy modules to dissect the creator's intent, perhaps using natural language processing techniques to identify manipulative language patterns. Simultaneously, emotional empathy is simulated through LLMs, which generate responses that mimic human reactions, such as sentiment analysis or predictive modeling of user engagement. The empathy-aware filtering mechanism works by refining these simulations. It introduces diversity by incorporating variables like cultural context or individual differences, ensuring that the detection isn't biased toward a single viewpoint. This is crucial because misinformation can vary widely across demographics, and a one-size-fits-all approach often fails. The paper's abstract sums it up by stating that DAY offers a more comprehensive approach, with experimental evidence proving its superiority. Overall, this work highlights the potential of blending human psychological insights with cutting-edge AI to create more effective tools for misinformation detection in our increasingly digital world. To wrap up the explanation of the key contributions, the authors argue that by focusing on both cognitive and emotional empathy, DAY not only identifies misinformation more accurately but also promotes a healthier information environment. This could lead to broader applications, such as in education or policymaking, where understanding empathy's role in information processing becomes essential.